Hi, everyone, and welcome to People Behind the Science. I'm your host, Dr. Marie McNeely, and I am glad to have you here for episode 676 featuring Dr. Thomas Brück. If you like this episode, listeners, and you want to check out more stories from amazing people doing great science, you can find more episodes of our show on Apple Podcasts, Google Podcasts, Spotify, or wherever you like to listen. And today, Thomas has some fantastic stories he's going to be sharing with all of us today. So get ready to meet another one of our brilliant people behind the science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am looking forward to speaking with our guest scientist, Dr. Thomas Brück. So, Thomas, welcome to our show today. How are you?
Hello, Marie. Nice meeting you and joining your show.
Well, Thomas, we are thrilled to have you with us today, and I'm looking forward to telling our listeners a little bit more about you, your current position, and how you got there. So, listeners, Thomas is the Werner Siemens Chair of Synthetic Biotechnology at the Technical University of Munich, or TUM, in the School of Natural Sciences. He received his bachelor's degree in chemistry, biochemistry, and management science, and his master's degree in molecular medicine from Keele University in the UK. Thomas was then awarded his PhD in protein biochemistry from Greenwich University, also in the UK. And next he conducted postdoctoral research at the Center of Excellence for Marine Biotechnology and Biomedicine at Florida Atlantic University, where he subsequently served on the faculty as an assistant professor. Thomas then accepted a position in industry at the chemicals company Süd-Chemie In Munich, and he worked there for about 4 years before joining the faculty at the Technical University of Munich, where he is today. Listeners, Thomas's research group was cited in the IPCC World Climate Report 1.5 for their work on industrial routes for a permanent CO2 sink. And in addition, the NGO European Business Council for Sustainable Energy recognized Thomas with the E-Award in 2018 for this work. In addition, he was the inaugural recipient of the Technical University of Munich's Sustainability Award in 2019. And he's also been elected as a member of the German Bioeconomy Council, where he provides advice to the federal government on sustainability matters. So, Thomas, we're excited to welcome you to the show, and I'm excited to learn more about you as a scientist, of course, but also about you as a person. So, can you start by telling us what you like to do when you're not doing science?
When I'm not doing science, I'm actually trying still to be a good family man. I'm the father of 2 daughters, so the time spent with them is very precious to me because as an academic, you always have things to do, and it's finding the time for the family to educate and also enjoy the time with your family. And for me, as really it is important to also convey to the next generations that the challenges that we face now will be even more pronounced in the future. And that is this generation to come that has to solve and mediate solutions to climate change and sustainability.
Definitely. I think these are important topics of conversation, important issues to address going forward. And you mentioned you have 2 daughters. What are some of their favorite activities these days?
Well, I have a 9 and a 13-year-old. Their activities are very different. Louisa, the 9-year-old, still likes to draw, but she also likes to go out into nature and explore the surroundings that we have here around our family home. There's a stream, there's woodlands, and look at what is going on there, the birds, the fish, whatever is going on, and the changes that we also see in agriculture at the moment, particularly here in Germany, where we had a long drought summer with wood fires and also low yield agricultural activities, which impact costs of our food resources at the moment. And all that is already apparent to the younger generation. And I'm trying to explain to them that these issues will become more pronounced, but there are solutions if we change our patterns of life in how we deal with consumption, how we deal with using food resources, and how we practice agriculture.
Absolutely. And we touched on just some of the work that you are doing in the laboratory, but I think it's common for conversations to start with scientists and they have to describe what they do to people who aren't familiar with their work. So how do you describe your work to someone who's outside the field or maybe outside of science altogether?
So really what we are trying to do is utilize CO2 to bind CO2 from the atmosphere using biotechnology methods. So basically using the tools that nature gives us and improve them to make a more efficient process to then generate biomass in the second stage of that conversation process. And that biomass, which is mostly coming from plants or algae, is then converted into value-adding products that we use in daily life. And that could be a protein mixture that you have for breakfast, or, for example, carbon fiber that is used in your car.
Oh, very interesting. I think this work that you're doing has a wide array of applications, which I think can be really motivating and exciting. But I guess thinking more broadly, Thomas, what motivates you or maybe inspires you to do the work that you do? And do you have a favorite quote or a saying or a mantra that you can share with all of us today?
What drives me to get out of bed every time is to provide a livable planet for the next generation, the generation of my children. It's really the depth of my heart.
I think that is phenomenal and so important for us to kind of take a step back and think about those future generations and what we can do now to make this planet, to make what we're doing more sustainable. So I think that is phenomenal. And thinking back on your career, are there particular role models or mentors or people who really had a big impact on you or maybe inspired you along the course of your life?
We all have role models in our lives, particularly as scientists. Certainly starting out from my PhD time in the UK, I was in a female lab, which was at the time also not common in the UK. I had a PhD mother, so to speak, Pat Harvey, who really at the time was raising a family while trying to have a very vibrant research team and seeing what that meant in terms of managing your kids as well as your research team, which is like a second family, really. Helped me a lot in understanding how I deal with time management. The second stage, and I think this was the most great impact on my scientific career, was my postdoc and assistant professorship advisor, Professor Russell Kerr, who told me diligence in science, that it means to have dedication, that really you can't stick to a 9-to-5 job to make an impact. And that if you believe in something, you can change society. And he also taught me translation. So taking knowledge from the lab, turning it into products, all while forming a company or another vehicle to actually make that translational research happen is very, very important to have a societal impact. And I'm very grateful for that. He was an inspiration in my career, and he still is. He just finished his tenure in Prince Edward Island University in Canada now, but he's still active and dealing with marine science. And this is still something that's very close to my heart. I'm an avid diver, and I have seen the marine ecosystem degrade over the last decades. Just one example from my personal life. There was a site in Fort Lauderdale where I used to dive every day while I was an assistant professor, either before or after my working hours. And after 10 years of being back in Germany, I just went for a dive with one of my friends. And that was on the 16th of December, 2020. Not only was the outside temperature 16 degrees and the water was 31. So the ocean was steaming. And when I was diving, about 90% of that reef that I knew for a long time was dead.
Wow.
And it had one of the greatest impacts on how I would deal with science, my scientific admiration at this point. 2020, I would say I was already an established scientist, and even more so, it ingrained that vision to really make a change happen in sustainability on how we live, because we cannot abuse nature any further. If you talk about wood fires in California, drought in Midwestern America, the same things happen now in Europe. We see the same effects in Spain, in Germany, in France that you have seen maybe 2 or 3 years ago in the US. and it's getting worse. And it's more and more of an internal driver for me to find solutions on how we make this planet livable again. Also livable for not our future, for the future of our children, and to find solutions for the things we have done wrong in the past. And sometimes that's more difficult than others. And the coral reef is a very complex and distinct ecosystem that cannot have simple solutions to repair this. But I think connecting scientists over the world together to work on similar problems is a point towards a solution. I personally think technology has brought us to this point where we have destroyed this planet. It is also technology that will enable us to repair this planet without impairing our living standards, but even maybe thinking more globally to improve the living standards of those regions that have been neglected and abused by industrialized nations. And here I particularly talk about Africa, South America, and Asian regions, where we just looked at their resources in the past. Now we have to look at providing technology to them to help us. As a European, the solution for our energy problem is not in Europe. It is in Northern Africa. They have the space, they have the sun, they have also the population that at certain regions is highly educated and could provide solutions for us in Europe. And I think similar activities are already happening in the States, where you look elsewhere to cooperate and find solutions together to our energy, food, and also our water supply issues. So I don't think the future is bleak. I think the future is bright if we work together.
Absolutely. And I think personally seeing and experiencing those impacts yourself is really powerful. And you can just hear, Thomas, how much your work means to you. And I guess I'm curious, where did this interest in science and maybe in sustainability specifically start for you? What were some of these very first memories of you getting interested in this?
I think it's ingrained in my family. My father was a chemist at the chemical company Bayer, working on rubber chemistry. My grandfather was the founder of the engineering school in Cologne, and he was the one who gave me my first microscope at the age of 6. So there was always an interest in nature, and it was always my family who took me out and looked at our surroundings. And I was very early on, between the age of 4 to 6, where I learned the names of plants, the names of minerals and stones and everything that was around me. So that was really ingrained me into starting to see the world through, analytical eye.
Definitely. And what were some of these key moments or maybe turning points that really got you to where you are today?
Certainly, life is not straightforward. I started my career in Germany in 1992. I do remember starting chemistry at the University of Siegen. And I very rapidly decided that this was not for me because I wanted to do biochemistry. I wanted to understand the molecular workings of life. And at that time in Germany, we had our gene technology laws where sort of genetic engineering technologies were not taught and not applied because people were afraid of it. So I decided to go to England to learn what I wanted to know. And this is one of the key steps in my, let's say, non-linear life. So I did my basic education at Keele University in the UK, basically studying biochemistry, chemistry, and management science at bachelor level. Then went on to do a Master of Philosophy in Molecular Medicine at the medical school at Keele University, and then went to London to do my PhD in protein biochemistry, and finished there with my PhD degree at Greenwich University. After that, I went on to do a postdoc and assistant professorship at Florida Atlantic University at the Center of Excellence for Marine and Medical Biotechnology. Thereafter, I went back to join a company called Süd-Chemie in Germany, where I was the first head scientist heading the biochemical and applications science department, and afterwards moved up into management, holding the global portfolio management for IP and technology for that unit. in that time, I was involved in developing and scaling a process for converting straw to ethanol, a biofuel of the second generation, so not dependent on food resources. And after 2011, just before Süd-Chemie was taken over by a larger company called Clariant, I moved back to academia, to the Technical University of Munich, where I now hold the Werner Siemens Chair for Synthetic Biotechnology. And here my group is involved in several activities that are related to circular bioeconomy, converting residual biomass of marine and terrestrial origin, so straw, microalgae, into value-adding products for both the biofuels industry, the chemical industry, and the pharmaceutical industry. And lately, also developing new solutions for the food industry to move into a sustainable future.
And then I'm curious to hear a little bit more about your experience. So you took sort of a traditional, some people may call it academic pathway, up until you took that industry position at Süd-Chemie. So can you talk about what this industry position was like?
At that point, it was 2006. I was in my mid-30s. And in science, you're always kind of a vagabond. You move around to increase your experience and your skills. But at some point, you are wanting to create a family, and then you need stability. And that was one of the reasons why I took up this industry positions. But I also thought maybe to learn different skills, a different viewpoint on how to deal with science was not bad. And it certainly proved right up to this point, because scientists as a whole, if you just talk about basic science, do neglect the translational aspect, that you take your idea and your innovation to a product. And this becomes more and more important, particularly in the view of sustainability, because you have to imagine the following. If an idea is not translated into a product that you can buy or that can be used by society, it doesn't contribute to societal change. So keeping in your ivory tower is certainly not impacting the needs of our society to become renewable, sustainable, and circular. And this is something that I took back from the US. It's that entrepreneurial spirit that was ingrained also in the academics and all the activities that we have conducted in the US. It was not so much present in the UK or Germany at that point, but it actually becomes more and more pronounced now here as well. And it's just the science of the time. It's a new generation of professors that are rising, and it's also the need by politicians as well as society as a whole to find solutions to our current problems.
Absolutely. And you ultimately returned to academia. You're there at the Technical University of Munich. So can you tell us a little bit more, Thomas, about a project that you are working on right now that you are just maybe the most excited about?
There are a couple of projects that I'm certainly excited about. So maybe just two of them. So we have a new project that's also a large interdisciplinary project to combine the production of alternative proteins using algae and microorganisms with vertical farming. This is something that is going forward and that is funded actually not here in Germany, but in Singapore by our TUM Create Singapore branch. And here I'm working with 8 different professors from both TUM as well as the National Technical University of Singapore, NTU, to just bring new ideas together and have a vision for feeding urban populations using vertical farming systems. Yeah, completely independent from classical agriculture. So this is one way forward. The other is certainly the use of algae and other oleogenous organisms for producing green carbon fibers. This is something that's at a scaling aspect where we already showed proof of concept at Trial 6, so at a demonstration scale. And we are now, together with our industrial partners, scaling this to an industrial level and hopefully bring this to market within the next year and a half.
Oh, interesting. So what are these green carbon fibers used for?
So basically, you can imagine that you take CO2 out of the air by using algae that fixate it using photosynthesis. The oil that is produced by these algae can be converted to both high-value products such as lubricant additives and green carbon fibers. And these green carbon fibers lock in CO2 permanently, basically. And you can use them for lightweight applications, either in building chassis for electrical cars or for building lightweight planes that come into life with a negative CO2 footprint. If you then combine this plane that's made of green carbon fiber together with a biofuel made of algae or any other renewable resource, you can enable CO2 neutral to CO2 negative flight, which is very important for the transport of our future, because planes will not run on hydrogen. They will not run on electrical energy if they have to go long distance. So a flight Munich to New York, for example, would only happen on liquid fuels. And these fuels need to be compatible with current aero engines, so jet engines, and need to be certified. And we can do this with our algae today. And we can do it not only technically, we can do it also at cost. And that's most important. You not only have to have the technical feasibility in mind, you also have to make it feasible within economical frameworks, that whatever you produce is not more expensive or not significantly more expensive to current solutions.
Definitely. And many of our listeners may take algae for granted. It's just sort of the green stuff you see on top of the pond or something like that. So I guess, are these algae very specialized, or are they pretty run-of-the-mill algae that you're working with?
It's a very specialized algae. We have a proprietary algae collection of about 500 strains that are just belonging to us, that we have collected from nature all over the world together with collaborators. And it's actually an algae strain that we collected from the south of Australia that is currently most promising. A strain that's called Microcoropsis salina, but it's not the strain that you can buy in a strain selection. It's our own strain that performs 15% better than anything you can buy from a strain collection. And it's all about how to treat that algae and how to scale that process to make it happen.
Absolutely. Well, thank you for telling us more about these two very exciting projects, Thomas. And I know as a scientist, you encounter many challenges in the work you do, particularly in this area of sustainability. So when you think about your own serious challenges, problems, failures, things like that, do any really rise to the top of your mind as a big struggle that you went through? And if so, can you tell us more about it and how you worked through it?
Basically, diligence and frustration tolerance is certainly key attributes that you need to have as a scientist.
Mm-hmm. Frustration tolerance, I like that.
Yeah, because 90% of the stuff that you do doesn't work, and you just need to find that 10% that does work and develop it further. And that takes time, sometimes several generations of PhD students. We are just about to publish a method for genetic engineering of oleaginous yeasts to make tailor-made fats that can substitute palm oil and cocoa oil. And I think that will transform the industry in terms of in the food and also the biofuels market. But that was 7 years in the making. It took actually 3 PhD student rounds to find the solution. And that is the sort of challenge, to find the right person to do that work, to guide them, to see that that person is taking your advice. And also that you have a person that's diligent enough to say, I want this result to happen, and I want this result to happen beyond my normal working hours. We are all driven, and that means sacrifice within your private life. And that's particularly true when you do a PhD, at least in my group.
And I think in addition, it can be some amount of trial and error, right? You try something, it doesn't work. You try something else, it doesn't work. It's just sort of the combination of this diligence, this persistence, and just not giving up on it.
Correct.
Absolutely. Well, we don't just want to talk about the challenges, though I think this 7-year project definitely qualifies. But Thomas, is there a success story that you'd like to share with us? Maybe one of these big wins or small but particularly meaningful successes that you've had?
There's, of course, the scientific or technical wins. We found an algae that's producing 70% of protein rather quickly by screening our databases and our strain banks. That was a very short success, and we'll publish on that shortly as well. And that's a very, very important issue, because protein is something that's key to feed the future generations. It's in dire need, particularly in developing and emerging countries where they're not supplied with protein appropriately. And finding solutions that are not impacting agriculture as we do it today. And that was really a fast win on that respect. But it's also every time I graduate a student with a PhD is certainly something that makes me feel very happy and accomplished, because you guided this person to a certain level and provide a new start in that person's career. I always call the PhD the license for independent scientific work. And I think to get a person to that point of independent thinking is an accomplishment also as a supervisor. And we just finished a PhD with distinction with a young lady called Marion Ringel very recently. She was in my group since her master's studies, and I very early on saw that there was talent in her. And I fostered that talent, not only by giving advice and guidance, but at times providing challenges. I gave her very free rein on how to conduct projects and also lead her own master's and bachelor students. And at the end, she always surprised me on the outcome, that she superseded my expectations scientifically as well as personally. And that is a very big accomplishment also on my side when she finished, that I, as a person, took the right approach between guidance and freedom to allow her to develop scientifically. And she's now entering a postdoc stage in my group and hopefully will finish her habilitation. And that is the final bit before becoming a professor here in Germany. I think she has a bright future in front of her. And in that, I would like to give her guidance and foster her as much as I can.
Absolutely. Well, congratulations to you, Tomas, and to Marianne as well. And I know it can be scary kind of giving people that freedom, giving them the reins, and you don't know what to expect. And it's amazing to see these young scientists kind of grow, develop, and start thinking independently. And like you said, surprising you with some of the solutions and some of the amazing results that they come up with. So that is definitely a big win. And we talked about some of the things that you like to do when you're not hard at work doing science. I know you're often reading things, whether it's manuscripts or grants or student papers, things like that. But what are you able to read for fun, Thomas? And do you have a book recommendation that you can share with me and our listeners?
There's a book from Stephen Hawking, Short Answers to the Big Questions, which is rather philosophically deep, but not scientifically deep. And it's very enlightening. It's a light read, but I really enjoyed it. And besides that, there's certain things that I certainly like to do. Besides science, diving is one of them. As you know, I just came back from Sharm el-Sheikh in Egypt, and they had a lot of diving in reefs. And I was very happy to see that some of these reefs are still intact.
Oh, absolutely. And you mentioned travel. This is something else that is a big part of a career in science, whether it's for conferences, to work with collaborators, or like you, in your case, you went to all these different places to do your academic training. So Thomas, when you think about your scientific travel, is there a favorite place that your work has taken you?
Well, certainly there are three favorite places. So I really enjoyed Canada because I can very much relate to the people. They're very open, multilingual, most of them, and they have a rather open mindset. I also enjoyed my time in Florida because obviously living there for several years, I have very strong ties and personal ties still there. And every time I go and see my friends there, it's a good time. And then last but not least, certainly we have very strong collaborators in Australia, particularly in Brisbane at the University of Queensland. And that's quite a funny situation because most of the collaborators there are of German or Swiss descent.
Really?
So when I go there, I actually speak German.
I love that. So what are some of your favorite things to do or see in Australia?
Well, Australia actually is such a varied country. Just going on Aboriginal trips to the rainforest or seeing nature in Kangaroo Island or just having a river trip to downtown Brisbane. It's just such an experience because you have that mix of cultures between Asia, Anglo-Saxon and European in general, which is even more pronounced than in the US, which is really fun. You can go to an Irish pub in downtown Brisbane and have a night out with the fiddlers. And on the next day, you can go to one of the islands to have a trip with the Aborigines. And the next day, you go to a Bavarian pub. So it's very, very varied. And I love the openness and the easiness of the Australians. Besides all of the issues of politics, their environment changing, they still have a very open mindset, which I really enjoyed. And even if some of them disagree on politics, they still talk to each other. And this is something maybe as a limited closing point I want to make to the listeners in the US. I have lived in the US several times. So also when I was 16, I had a student exchange for a year in Spokane. I lived in Florida for 4.5 years. Through all these times, I saw people with different views talking together. And even if the evening on several beers ended up saying we agree to disagree, there was always a mutual respect. Coming back now, I lack that respect with people, particularly when I came back to Florida. There was a distinct barrier between people talking. I think there is a mindset that is very closed in terms of political views. At the end, you have to consider we all live on the same earth. We all have the same problems, and we cannot really solve them if we don't work together. And this is very close to my heart. I love the American people. I really had very good experiences. But recently, these experiences were, let's say, tainted by these really strong divides that I've experienced as a European. And thank God this is something that has not happened here. While there are strong divides in Europe as well, we still have the unifying idea of a single Europe. And I hope that stays this way. For me, it's crucial as a scientist also to look at societies and how you deal with each other, because at the end, the message is one Earth, one planet, one nature. And we only have this planet. There is no planet B. And I wish for more collaborative thinking, independent of ideologies. They do not help us.
Certainly. I think we're all in this together. And like you mentioned, just the importance of finding that common ground, having some of these difficult conversations where you might not come out agreeing with each other, but at least you've been able to kind of hear each other's perspectives and maintain that respect. So I think that is so important. And you talked about some of your scientific colleagues and some of these experiences that you've had all over the world. And I think meeting other scientists from different places is just an amazing experience and part of the career as a scientist. And there's some stereotypes out there about what scientists are like and what being a scientist is like. And we try to break some of these on our show because I think some of the most funny, creative, amazing people that I've met are scientists. So when you think back upon your own experiences, Thomas, are there particular, quirky lab traditions or just funny or fond memories that you shared with colleagues that maybe go against some of the stereotypes that people may have about scientists that you could share?
Yes, there was an inaugural ceremony when we went on our Bahamas research cruises every year.
Ooh.
So all the novices had to dive for conch shells, and we had them usually for lunch. And there's a particular piece of the conch that looks like a penis. And independent if you're male or female, you had to eat that penis to be member of the group.
That's an intense initiation.
It's intense initiation, but it was very funny. And the faces that I've seen during that time, I will never forget.
So what if you were not successful in finding conch shells in the dive, or was this something that wasn't a question? They were always down there?
Yeah, certainly. Then it was providing beer to the whole group. And that usually helps in communication very much.
Well, I think this is a funny tradition. And you mentioned these cruises to the Bahamas. So was this just like a 1-week research cruise, or what were these like?
Yeah, it was actually a 3-week research cruise that we did twice a year to collect samples. So we particularly researched a soft coral called Antillagogia elizabethae that makes a anti-inflammatory drug. And we looked at the enzymatic pathways that lead to the formation of that drug in that coral. Basically finding ways to do this recombinantly. And we are getting steps closer every time. It's a very complex scientific question, but we've been working on this for 15 years diligently. And the last 2-3 years, we made some giant strides. And that was actually the PhD of Marion Ringer. And even if you have a hard nut as a scientific question, you need to crack it at some point. And if it's finding conch on the way, there needs always be a path forward.
So did the conch taste good? Was this something that you enjoyed eating?
Actually, the conch itself is very nice. If you have it fresh, it tastes a little bit like coconut. The conch penis itself is a clear, long appendix that has no taste. So any people that just look at it, they're scared of the appearance, but it really doesn't say anything.
Oh, that's good. There's a silver lining to this.
Yeah.
Well, it sounds like you've had some great traditions, great experiences with colleagues over the years. Do you have a particular tradition in your lab now or a way that you guys celebrate some of the successes?
Of course. When people graduate, we provide the Holy Trinity, which is basically an engraved pen set with the person's name that graduated and the date. Usually a watch that I provide, a luxury watch, to remind everybody that time in life is precious and that there's more to life than science. And the third is usually a bottle of spirits, and that's either whiskey, a single malt whiskey, or a good bottle of rum. They can choose, usually aged. And that also is a symbol of take time to let go and think, because only if your mind reigns free, you can have the ideas to move mountains.
Oh, I love this tradition and sort of the symbolism behind each of the items that you give your trainees. So that is phenomenal. And I know you are addressing some really big questions in your lab, Thomas, with the work that you're doing. But oftentimes you're faced with barriers, whether it's funding, staff, technology, feasibility, or just getting everybody on the same page to agree on what needs to happen. So if we took away all of the barriers that normally hold you back, what is the one question you would want to answer most?
We probably would have be back to Stephen Hawking's visions on how the universe works, but really I'm not that accomplished. I rather would like to know how nature works. How does nature actually accomplish the variety of molecules that we have out there and provide bioactivities to those? It's one of the big questions that we have when we look at enzymes or biocatalysts that we deal with. Sometimes we do not understand the basic workings of those. And I think it's decades away that we can predict reactions that occur in nature thoroughly by in silico methods. We are on a good route, but it's certainly more understanding. And that means experimental understanding that we need to provide that predictive power. So every time I look at nature, I am humbled because I know that every time I take something in my hand to analyze and understand, I will only scratch the surface.
Definitely. And I think just in nature in general, we're still only scratching the surface. I think there are still so many undiscovered, unstudied compounds, plants, things that are out there. So I think there's still so much exciting science to be done. And you've had a chance to answer some really big, important questions with the work that you're doing. So I guess if you had to choose, Thomas, what is one project that you've worked on that you think has had the biggest impact?
Certainly, one of the biggest impacts that I had was looking at how corals make bioactive compounds that could solve pain, inflammation, diabetes, or cancer. Yet we cannot make these compounds synthetically or by biotechnology means to the amounts we need to make them into practice, to actually bring them into clinical practice, for example. And that's the sort of thing that is one of the routes that I would like to dig deeper. And maybe before I retire, at least some of these parts are uncovered and understood.
Absolutely. Well, that is an exciting area of research indeed. And we look forward to hopefully some of your advances coming down the pipeline here. And I guess at the end of our interview here, we'd love to share some advice with our listeners. So Thomas, do you have a piece of advice that you received from someone that really helped you that you could share with us today?
If you fall, dust yourself up and carry on. Never giving up, I think, is a hallmark of a scientist. And it's not only frustration tolerance, it's an attitude that you have to have. And that applies not only to the science, it also applies to your personal life. If you have negative experience in your personal life, do not give up. Believe in yourself. Carry on.
I think that is wonderful advice. We appreciate you sharing that with us today, Thomas. And is there any other last message you want to leave our listeners with at the end of our conversation today?
Maybe because sustainability is at the heart of what I do, I would like your listeners to think about their daily life. What can you improve in terms of waste removal, waste recycling? Do you need all these items that you buy? So consumption is certainly an issue that we have in our society. Rethink how you live. Do you really need everything that you buy, everything that you need to consume? Because everything you consume is partly consuming your planet. That applies not only to our generations, but also to the generations to come. Just think before you do.
That is an important message, being thoughtful about what we bring into our lives, what we're buying, what we're bringing home with us every day. I think even some of these small changes can have a huge impact. So I appreciate you sharing that message. If our listeners want to learn more about you, Thomas, and more about the work that you do, what is the best way for them to do so?
Certainly go to our website or contact us personally under Brück at tum.de. You can write me an email. But you also can go to look for the Werner Siemens Chair for Synthetic Biotechnology at the TU Munich on Google. We have our website and there's some basic information that you see there. But you can also go on YouTube and there's several documentaries on the work that we do there as well.
Excellent. Well, listeners, check out these resources. Thomas, we appreciate you sharing them with us today. And thank you so much for spending time with all of us in this interview.
Mary, thank you very much. Most appreciated.
Well, it was a pleasure to chat with you, and listeners, wonderful to have you here as well. We would love it if you have a chance to leave a review on your favorite podcast platform. And I look forward to seeing you in our next episode of People Behind the Science.